Okay, so we are on, and good evening, everyone, and nice to have you all in here. We have today a great guest, and we have a big task to discuss about it because Ali, my guest, our guest, will be talking about AI and how to learn through play and experiment. It's great because even kids are doing as well, like this approach. So I am very curious about this, how he will be presenting this topic. But at the beginning, I would like to say, of course, hello, Lee, and can you tell us something about you and what brings you here and why you want to present this topic for us?
Yeah, absolutely. Thanks for the whole TWF community for inviting me to come and talk. I'm a Microsoft MVP, so I love giving talks like this and sharing technologies that I've learned. And I don't claim to be an expert in a lot of these technologies, but I do like to still share the things I've learned just to lower the barrier to entry for other people. And because of this big rise in popularity in artificial intelligence, I thought I would take the time to share what I've learned about it, and not just the theory about why it's good or why it's bad or how it can be used, but show some little side projects that I've done to help learn it myself. And that includes image classification, machine learning, Gen AI, and learning agents. And then other people can then take that and go off and continue to learn about them if they want. Because I honestly think that the best way to learn is through play and experimentation. And I think you get a lot of benefits from doing that rather than formally going off and learning things. If you can make it fun, I think that's just the best way to learn. And that's hopefully what I'm going to be presenting today.
And I see that on your LinkedIn that you're also put a lot of posts about AI. So it could be interesting to just hear from you this, this approach because from my side, everything which includes developing is it's doing like this. Just take, play, experiment, and try to do something else. And from this side, just big things appears. So okay, so let's go. I won't be talking too much because I am very curious about your presentation as well. So stage is yours, and Lee, nice to have you. Nice to have you in here with us. So go ahead.
Sure, I'll go ahead and share my screen and get that up there.
Oh, something's wrong. Can you bring?
I shall try that again.
Yeah.
I think that I've done the trick.
Okay, I have this one.
Okay, we're off. Yeah.
Yeah,
Everyone
it's
see
you.
that? Fantastic. Cool. So like I said, I'm going to be talking about learning AI in particular through play and experimentation. There's lots of different ways of learning things, and this is just one way that I like to learn things, and hopefully encourage you to go off and learn AI through play and experimentation as well. It is a bit of a mishmash of smaller different talks that I've done, so hopefully you won't be able to see the difference, but it might jump from place to place, so I apologize. I'm also not an expert in any of these technologies. I just like to share what I've learned. So if there are going to be questions, if you could hold off to the end and I'll try and answer them, but bear in mind, again, not an expert, just sharing some stuff that I've learned. So as Magdalena said, my name is Lee Engelston. I'm the Developer Relations Lead at Avanade, based in the Microsoft UK. I'm a Microsoft MVP in Developer Technologies and Mixed Reality. I'm a published author in augmented reality development, and I'm doing a part-time master's degree in entrepreneurship and innovation. I'm on all the social medias at Lee Engelston. I should be very easy to find. There's not many of me. If you want to find out a bit more information or follow me for similar talks like this, please go ahead and do that. Really quick word about my employer, Avanade. So we're a global IT consultancy with 60,000 people across the world and 26 countries. We were formed by Accenture and Microsoft 20 years ago, very much specializing in the Microsoft ecosystem of technologies. We are pretty successful. We've been the Microsoft Global Partner of the Year for the last 18 years, and we have something like 70 Microsoft MVPs working for us. So there must be something in the water that attracts these people that are top of the game, best of the best in Microsoft technologies, to come up to work for us. So if you are considering a career change, come and talk to me, or go to avanad.com for more information. So I would share sort of my journey that's brought me here. We're all on a journey. We've all got different journeys, but very much I have a very strong sciences background. Junior, middleweight developer, senior developer, started leading teams, started leading the technology business function. Along this path, did Microsoft certifications, built websites to help the community like visualstudiotips.co.uk, did talks, did videos, learned lots of content, became a Microsoft MVP, had my book published in augmented reality. I still do a lot of mixed reality development because I'm very passionate about that, because I think that's the future is going to be very much about immersive experiences, and doing my master's degree now, as we said. And that's my life in a journey, really. I don't know where it will go, but what I do know is that whatever I do, it will be something I'm passionate about, because I strongly feel that you should do whatever you're passionate about and nothing else. There's going to be a few core themes to this talk. I'm going to talk about play and why it's important. I'm going to talk about experimentation and what I mean by that, and why you should have fun when you're playing and experimenting, and why it's important to have fun. And if you are playing and experimenting and having fun, you will learn as a natural side effect of that. And why I think that if you're having fun while experimenting and learning, that is the best way to produce innovative results, and I think the cornerstone of innovation. So over the last 20 years, I've dabbled in lots and lots of different technologies, and including AI, and we'll talk about AI today. So what I have, like Liam Neeson in Taken, isn't the skills to rescue my daughter if she's kidnapped, but I do have a very particular set of skills, and they are artificial intelligence, machine learning, virtual reality, cloud, mobile, IoT, Windows development, web development, generative AI. So I'm going to be sharing that why I built these a range of skills when I've not needed to. None of these, except maybe one or two, have been my full-time role, my 9 to 5. I've gone off and learnt these technologies in my own time, and that's really helped my career. And I'll explain why I've done that and why I think you really want to be doing this if you can. So we're going to be looking at a few side projects, as I mentioned. We're going to be focusing on a lot of my side projects that are to do with artificial intelligence. I won't be covering my virtual reality, augmented reality ones. Maybe in the future, TWF will want me to come back and talk about extended reality. I'd love to do that. But we're going to focus on some AI side projects I've worked on and what I've learned from them. But first, we've got to rewind back to our childhood, or your childhood, because children have this natural curiosity about this world. They want to explore it and understand it, and that they're generally filled with wonder about how the world works, and they love to explore and use their imagination. They want to mix different colored paints to see what color they come out with, and they're naturally curious about the world and play and imagination. But then as we grow older and become adults, something terrible happens in my eyes, something absolutely horrible. We lose this curiosity, this desire to use our imagination. As we enter the workplace and formal education, we're told to think in certain ways, to do things in one way and not another, to focus, don't daydream, pay attention, do this work, don't do that. And I think that's a real shame, because I think if you should really try and maintain your curious nature around of the world as much as possible, and because that will help you with your play and experimentation. So my initial advice would be, please don't stop daydreaming. Continue to use your imagination as much as you can, because it's like a muscle. If you don't use your imagination, you won't lose it, but you'll become less able to use it. So that I don't trigger any scientists on the call, I want to explain what I mean by experimentation, because it probably means something very different to them. When I talk about experimentation, I very much mean informal experimentation. So a lot of my experiments or side projects start off with me asking, what if I did this? Or normally, wouldn't it be cool if this? Wouldn't it be cool if I could build a machine learning image classification model that could tell me the different type species of bird I'm looking at? Or wouldn't it be awesome if I could have a globe that floats in my living room in augmented reality? And in some ways, that's a bit like a hypothesis. You're asking yourself a question, and could you do it or couldn't you do it? In reality, a hypothesis is something to be proved or disproved, but it's a little bit like a hypothesis. And then in order to go off and answer that question, you have to go off and learn how that technology works. And that is a little bit like the analysis. So you're breaking down the technology, understanding how this part of it works or this part. And then what that allows you to do later on is say, well, now I understand how image classification works this way. What can I try it in this way instead? And that is a little bit like synthesis. And synthesis is taking all the smaller pieces that you've learned how they work and then putting them together in different ways and different combinations to produce different results. So that's kind of what I mean by experimentation, informal experimentation. It's a good question to ask, why experiment at all? And I think I've got some reasons why you might want to do this. I think it is important to ask the question why. And I think you should always start with why, because Simon Sinek wrote a really good book and did a great TED talk on why you should start with why in every aspect of your life and career. So why experiment? One reason is to future-proof your career. If you can experiment and play and learn better than your peers, that's going to help your career. To help others, it's a very altruistic reason, but is a reason nonetheless. If you can learn new skills through experimentation, then you can share like I'm doing and helping others, or you could maybe do some tech for good, or you could do some open source contributions, but helping others is a really good reason. Business success. Don't assume that any business you work for are experts in technology. That is our jobs. We are the sharp end of the stick. It's up to us to say, these technologies do this and you can use it for these reasons. You can use it in this industry or this market. Don't assume the business always know what the art of the possible is when it comes to technologies. So very, very important when it comes to business success. Curiosity. So just to satisfy your own curiosity, everyone's curious to certain degrees, and it's more than okay to experiment just to satisfy your curiosity. To increase your skills. So both the variety of skills, like you could learn different types of artificial intelligence, or the depth of the artificial intelligence. You could just learn Gen AI really, really well, or you could learn different types of AI. So increasing both the breadth and width, the breadth and depth of those skills. To stay ahead of the curve. Now, the rate of innovation just seems to be accelerating. There seems to be a new paradigm shifting technology that comes out almost every month. And often we need to be looking at the horizon and experimenting with those technologies, because by the time they arrive and become mainstream, it's almost too late. There's so many of the people who are already taking advantage of that brand new technology. So you need to experiment just to stay ahead of the curve sometimes. To expand your knowledge, knowledge is power. The more knowledge you have, the more you can use it for various things. That's a good reason to experiment. And probably just as important to all those things is to have fun. I strongly believe that if you follow your passion and enjoy what you're doing, whether it's experimentation, playing, or learning, you're gonna succeed. You need passion to succeed. So that's another reason to experiment, just to have fun. So on to some of these side projects I talked about. But first, I just want to talk about what motivated me first to get into machine learning. So you have to go back a few years, and Microsoft started creating these websites called WhatDog and HowOld.net. And what they did was they allowed you to upload an image of a dog, and it would tell you what breed of dog it was. And 5 years ago, 6 years ago, or 10 years ago, I forget how old these sites are, that was amazing. It's really, really run of the mill these days. Very common. You could probably build this yourself. But back then, everyone was like, wow, how does it know what breed of dog this is? It's amazing. And people ended up uploading images of themselves, funny, and it would say what breed of dog people look like, but that's not what it was intended for. They also did a site that was called HowOld.net, and people uploaded images of people or themselves, and it would say how old they thought the people in those diagrams, those images were, based on a training sets that they'd done. And everyone was, wow, how does it know how old I am? It always tended to age me on the older side, so I don't have fond memories of that site. But again, this is for me like maybe not the birth of ML outside of academia, but this is where I started paying attention to it and really wanted to learn how these sites worked. So I decided to go off and learn ML.NET, which is Microsoft's machine learning framework, and I wanted to learn how to use C#, not Python, because I came from a Microsoft background, but there was a lot of Python machine learning packages you could use at the time, and I wanted to learn how to do it locally because you could train these models in the cloud, but I wanted to see if I could do it all on my local laptop, if I had all the resources I needed, if my laptop was up to it, just so I could have a closed system to train it. So I did that, and I'll show you how I did that briefly. But again, I just wanted to reiterate, I'm not an ML, AI, or data science expert, so just bear that in mind. So the first example using ML I found was, okay, it was boring to me anyway. It was about how to identify cracks in grayscale images, which is probably really, really important if your job is to maintain the integrity of the concrete that's surrounding, Chernobyl nuclear power plant, which not burnt down, which needs to be encased in concrete. But for me, it was a little bit boring, but the code was sound. So for me to learn something, it has to be interesting. So I thought, how can I take this use case and make it interesting? For some reason, I decided to go with cartoon characters. So I decided to keep it simple. It's something that's easily recognizable. I wanted to build an image classification model which would determine if a cartoon character was either good or evil. This would keep it fun and simple at the same time. So that's how this concept of goodie or baddie came about. So I did that. I trained the model offline using ML.NET. Got it working in a console application. Then I decided to host it in an Azure function. Never done that before. Again, experimenting and learning if I could do it. And then I wanted to see if I could host a site that would call that function on GitHub pages. Never done that before. Again, learning, playing and experimenting. And you can go today and check out goodieorbaddie.com. You can pull down the code and experiment it with yourself. But just a really quick one about machine learning and neural nets, just in case you're unfamiliar with it. The basic idea is you take different groups of images and you use what's called labels. I labeled one set of images as good and one set of images as bad. And then when you train the image classification model, it's creating a neural network, and this is all very much inside a black box. You can't see the insides of it, but as you train the model, it's creating a neural network of paths. You've got an input layer, some hidden layers in the middle, and then some output layers on the other side. And as you train the model, it's creating weighted paths between those nodes in the neural network, which means any image you feed into that trained model will arrive at either a good classification or a bad classification, which means when they upload an image of SuperTED, it will take a different path through the trained model to arrive at good than Cruella de Vil from 101 Dalmatians would to arrive at the classification of bad. Really quick word on bias, because whilst I'm not a data science expert, I do need to talk about it. I was very conscious that I could be inadvertently introducing bias based on the data I've selected to train the model on. Could I unconsciously be choosing more female good cartoon characters than bad cartoon characters? Could I be choosing more bad cartoon characters that were red or a particular color than other characters? But I decided, because this was just an experiment, that wasn't really a big problem. But if you do create image classification models or any machine learning models that are going to be used in production, you need to be very, very careful and biased and follow proper data science guidelines to make sure that you are training it and taking bias into account, because otherwise, as they say, garbage in, garbage out, and you might be introducing bias. But anyway, just for my purpose, that really wasn't important for my side project. So I managed to train this image classification model offline, and the first 3 images I gave it that weren't in the training data, that were actually in the training, the testing set, the first 3 bad ones all said, yep, these are bad cartoon characters, and the next 3 said, yep, these are good cartoon characters. And if you've never done this before, it's very, very awe-inspiring, because it feels like you've created this really basic type of intelligence that like that a human could do. They could look at an image and say that's probably a good cartoon character, and this is probably a bad one. And you've created a program that can actually do that for you. And whilst this is very, very narrow type of intelligence, very narrow artificial intelligence, it does feel intelligent. It's a really scary feeling, and only people that have done this themselves will understand what I'm talking about. This is why I recommend you play an experiment just to get that feeling that you've kind of created a really basic intelligence. And then once I created this offline model, I decided to see if I could try and host it in an Azure function, which I did, and create a basic, simple page, HTML page, host it in GitHub Pages to call that Azure function, which had the architecture like this, very, very basic, not a very super detailed diagram, which resulted in this website, goodyourbaddie.com, which I also wanted to learn and play around with how you could drag an image onto the web page and it would then do the upload functionality. So I learned that as well. You can go and try that, download the code and tweak it yourself. It also, someone said to me, well, can it detect whether a cartoon character started off good and ended up bad? And I found that a really good question. So I found a cartoon character which started off good in the TV show. And spoiler coming if you've never seen Frozen 7,000 times like I have. There's a cartoon character that started off good, and he uploaded an image of him at a point in time when he was good, and another one where he turned evil. And the website was able to determine whether it was good at one point and bad at another. So I was quite pleased with that. So you can go check that out on goodyourbaddie.com. So my first takeaway from the talk is fun. You've got to have fun when you're trying these things, because it's been proven that the more you enjoy what you're doing and learning, you'll learn it better and you'll learn it faster if you're enjoying what you're doing. So try and bring in fun into whatever you're learning, playing with and experimenting with. Another takeaway I've got to mention is that when you're learning something new and playing and experimenting, it's going to feel difficult and it's going to feel uncomfortable because it's outside your comfort zone. But I've got news for you. That is all part of growing. Change is uncomfortable and discomfort equals growth. So if you're not trying new things and you're sitting inside that comfort zone all the time, you're probably not growing. So get comfortable feeling uncomfortable if you really want to grow, because that's where growth happens. So I learned how to create image classification models offline on my laptop. I wanted to then try out to see if I could do it in the cloud using Microsoft Custom Vision AI. So I created an image classification model that would determine whether an uploaded image of a tree was a Christmas tree or a regular tree. And this was remarkable because not only was it like 99% accurate, I still didn't really manage to fool it. I even gave it an image of a Christmas tree in the shape of Godzilla, and even was 95% certain it was a Christmas tree. I was really impressed with how this worked. The other benefit of using Custom Vision AI is that once you've trained your model and tested it, it actually hosts the endpoint for you that you can then call. So it's really, really good. I recommend playing with that as well. So my next takeaway is show, don't tell. So there's a bit of a pattern in our industry where a lot of people talk about things, talk. A lot of it's thought leadership, but it's talk. And they never show what they're talking about. They talk about the benefits of AI, how it's good, how it's bad, how it's going to change everything, but they don't really follow through with that and give concrete examples of how they're proving that to be true. So my advice would be to show, don't tell. You can tell, but you just need to back up with show. So you can imagine show and tell as kids do in school, going to show and tell, and then someone talking about their favorite transformer. That kid's going to bring in their favorite transformer and say, look, this can transform from a truck to a robot, and they show the kids and they all go, ooh. See, we're no different than kids. We need to show, don't tell. We need to do it a lot more and a lot better, if you ask me. Okay, so the next thing that I did was, now I created a model that I could use to test static images. I wanted to see if I could create a model and detect it in a camera feed. So I did this. I built a naughty elf detector. I'm not sure if you're familiar with that naughty elf, that's elf on the shelf. Hopefully you are. I created an image classification model that would detect it with, I think, 95 images of the naughty elf and then 55 images that didn't include the elf to rule out false positives, etc. And the other thing that Custom Vision AI does is once you've trained your model, you can actually download it, which is exactly what I did. I downloaded that model in a format called .ml model C. I found an app that someone had written, or the code for an app that would run on my iPhone, or written in C# and .NET, which then allowed me to swap out the trained model from the fruit model, which was detected fruit for some reason, with my one that would detect elves. And again, you don't reinvent the wheel if you can avoid it. Just stand on the shoulders of giants and reuse what other people have created and tweak it for your own devices. Okay, so I'm going to try and play this video. If it doesn't work, I apologize. I'll walk through it. I've got a naughty elf in my microwave, and I've got a recording of what my app was showing. And as I do this, it can't see it. I open my microwave, it detects it, and it plays a sound, and it shows that the elf is 100% certain the elf is in the scene. And I do that a whole bunch of times, but that's very much using image classification or object detection in a real-time camera feed. That's, again, these examples seem silly, but they have very, very, very real-world applications. You just need to learn the technology first and then apply them in real-world applications. My next takeaway is to find and pursue opportunities whenever you can, because they won't come along as often as you think. So sometimes you have to go out and find them. But when they do arrive, make sure you grab them with both hands, because life won't keep handing you opportunities. By following opportunities, I've become a Microsoft MVP. I've had a published book, and that is only through learning and experimenting, playing experimentation, and sharing what I've learned. So please do try and find and pursue opportunity whenever you can. Okay, another takeaway is share. This is really important. A lot of the stuff I've learned has only been made possible because of learning for other things that other people have shared. And it's important we continue this cycle, because sharing is caring. It is a bit trite saying, but I do believe that sharing is caring. And I also want to say that you do not have to be an expert to share what you've learned. A few people are very wary about sharing what they've learned because they don't consider themselves an expert. I've written a book on augmented reality, but I don't consider myself an expert on it. It turns out writing a book is a really good way of learning a technology, because it makes you go off and learn it even better. But I just want to reiterate that you do not need to be an expert to share what you've learned. So do share what you've learned in any channel, whether it's videos or blog posts or brown bag sessions to your colleagues, because they will thank you for it. And if you can lower that barrier to entry for other people, it is a worthwhile pursuit. The next artificial intelligence technology that I want to talk about, that I learned how to do, again, just in my own time and a bit of a side project, was learning agents. Because I found a video that someone created a while ago on YouTube, and it was very popular, it had like 4 million views almost. And someone described how they trained a car to navigate a 2D course, and more accurately, they spawned like hundreds of them, and then they all had random parameters about how much to turn away from the walls when they approached them. And then they selected the ones that went furthest around the course, because they all crashed. And then once they'd done that a few times, they'd use the ones that had gone furthest to use those traits to spawn future generations of cars. And then by a few generations in, they'd had cars that could just navigate the course without crashing. I thought that was amazing. Now, unfortunately, whoever shared this video didn't share their code. I searched for it for ages, tried to get it, but couldn't. But I did find a very similar example, and that's the one I want to share with you today. But before I do that, I just want to briefly talk about reinforcement learning, which is important for learning agents, because the whole point of learning agents, which I forgot to say, was that learning agents are great for solving a problem where you know what you want it to do, but you don't necessarily know how you want it to achieve the result. You kind of want it to work out how it's going to achieve the result by itself. And this is what learning agents are great at. And it uses something called reinforcement layer. So what we want to do is encourage good behavior by rewarding it and discourage bad behavior by punishing it. And I've never squared my pets with a water pistol. Just want to put that on record before I get calls from the RSPCA. But yeah, so this is reinforcement learning. And this is the most famous deep reinforcement learning agent created by Google was one called Agent 57. And what they did, they used reinforcement learning to create a learning agent that could successfully complete all 57 Atari games, Atari 2600 games, just by a number of inputs, which is joysticks. It's like up, down, left, right, diagonal, and then one button, and gave it feedback as to how well it was doing, whether it was progressing through the game or not. And it quickly learned that what to do in various scenarios to complete the game. It has no concept of it needs to jump over a hole or dodge a bullet. All it knows was inputs resulted in good rewards or bad punishments, which got it further in the game. And that's how it kind of learned how to complete those games. And I'll just talk about this simulation interface that I found, which is really good. And speaking with John David Anthony, he really likes me talking about his code and his simulator he created. So the cars are the learning agents in this context, and they're only aware of about 6 different things. And that's the distance between the walls, to the sides of it, diagonally and directly in front of it, and the speed it's going. And then what the simulator that John David Anthony created was, it spawns hundreds of cars, but when it does that, it randomly creates a neural network for each of them, and we'll talk about that next. And then as you run the simulation, he calculates the fitness, which is how far the car went, and then uses that to spawn future generations, and that's where we get a learning agent that can navigate the course. So when each car is created, the values that are used for the weighted paths between the neurons are all random and different. And the inputs are the sensor distances, which I mentioned, and then the outputs is how much it turns left or right or goes forward or reverse. And so you'll have some cars that will turn into the walls immediately and some cars that will try and avoid the walls. But just to prove that the only thing, we're not explicitly telling the cars to, hey, you're approaching a wall, you might want to turn away now. We're letting it work out itself, because I can, for each of those paths, there's a value, and this is all the car knows is always told, or when it's randomly created, and that's these values for each of those paths. And I don't know if these are the activation functions or what, but every car will have a different number of values for the nodes, which means they'll turn into varying degrees based on how close they are to the walls. And this is actually the brain or the neural network values for a car that actually successfully managed to navigate the course, and it will just do it over and over again. So I can take those values of that brain and use it in another car, and it would successfully navigate the course. Interestingly, in David Anthony's code, he borrows concept from biology for his neural networks that he's hand programmed in the form of neurons and dendrites. And I found that quite interesting. But then he needed a way of calculating the fitness of a function. And he did this by determining how far a car got around the course and how fast it went. So if 2 cars went the same distance before crashing, it was whoever did it the fastest was the highest fitness. And then once he'd been able to determine, once they've all crashed, because they all crash, he ordered all the cars and ordered by fitness, this fitness function he created, and then took the best ones and then merged the traits between some of the best ones with others in the next generation. And that's very similar to how a male and a female, when they have a child, it has genes from both the male and the female. So always not the best genes, but it just has genes from both. And then he does that repeatedly, and then that results in cars that get further around the course. He also built in this element of mutation, a random value randomizer, which allowed even better traits to sneak in that it didn't get from the parents. So that was kind of interesting. So in generation 1, the cars just crashed almost immediately. By generation 32, I don't know if you can see the video, I think you can. They made it round the first bend almost a second, but then by generation 128, we had a car that could get all the way around the course, a bit like this. So yeah, you can use learning agents if you know what you want it to achieve and you don't want to explicitly tell it how to do that. That's what learning agents are really good for, and I wouldn't have learned about learning agents unless I use this as a bit of a side project. So that's a pretty cool skill and knowledge to have. Then what I wanted to do is see, now that I've got a car that can navigate an old track, is see if I create a new track, could it navigate that course as well? I've not actually performed that experiment, so I apologize, but I will let you know how it does. I've just not found the time. I'd be interested to know. So my next takeaway is build your tool belt. And this is important for a couple of reasons. One, when you graduate or enter the workplace, you don't have as many tools as someone that's been in the industry for years and years and years. And that means that maybe you can't solve as many problems, but it's also a little bit dangerous because if you've only got one tool in your tool belt, you're always going to approach different problems from the same perspective using that same tool. But if you've got a tool belt with lots of different tools, you can solve different solutions from different perspectives using different tools in your tool belt. So if you take web development, for example, which was my early career, how I started off as a web developer, it isn't just web development. There's so many things to learn to build out your web development tool belt. There's different graphics types, there's real-time communication, DNS, front end, back end, cookies, unit testing, UX, UI, all sorts, performance. And again, if you start off in web development, there's no need to say you have to stay there. You might want to learn about web, Windows, mobile development, cloud architecture, AI, AR, VA, game development, IoT. And if you do that, then you will be building out your tool belt, and sooner or later you'll find yourself, you'll have a tool for every occasion. When someone comes to you with a problem, you'll be like, I could use this tool, I could use it solve it using this perspective or using this mechanism. But yeah, another good reason for playing experimentation is to build out your tool belt. So another kind of AI-esque side project I did was create a Wordle solver, because I wanted to know if I could do it using Apple's custom vision framework, and it uses optical character recognition in there. Because I was inspired by an example I'd seen where someone had built a Sudoku solver where you just hovered the app or the camera of a Sudoku puzzle and it would identify the squares and the characters in there, and then it would fill out with the answers. That was remarkable to me. Again, using OCR and Apple Vision, so there is AI going on under the hood, very basic machine learning. So I wondered if I could do it, but with Wordle. So I created an app that would identify squares on there, and it would identify the color of the square, do optical character recognition to identify that character, and then compare whether the characters that were definitely in the Wordle word or not, or in the wrong place or in the right place, with a list of 5-letter words that I'd had, thousands of 5-letter words, and it would give you words that could fit that would fit given what you've guessed previously. Still need to get that app in the App Store. But yeah, that was really good because I learned a lot about the Apple framework and optical character recognition in real time. Another takeaway that I want to impress upon you is just how much more important implementation is than the idea. I'm not one of these people that says ideas are worthless. I'm far from. But if you be able to specialize in either implementing an idea or just coming up with ideas, I would lean towards implementation. Take it from someone who's 3/4 of the way through a master's degree in entrepreneurship. The implementation is so much more important than the idea. Ideally, you'd be equally suited to create ideas and implement, but some people lean towards being able to create lots of ideas and then throw them over to people that are really good at implementation. If you're really good at coming up with ideas and implementation, then that's fantastic, but not everyone is. But yeah, implementation wins over ideas, I'm afraid. Another takeaway I want you to go away with is to keep it simple. When you're playing, experimenting, and learning new things, sometimes it's tempting to dive into the deep end of the swimming pool, and that's not the best way to learn how to swim. Try and keep it simple. Learn the underlying technology, do the analysis and the hypothesis, and then once you've learned the underlying ways the technology works, then you can apply it to more and more advanced scenarios and do that synthesis. So yeah, so keep it simple. I see this phrase thrown out around a lot, the art of the possible. It's a really interesting phrase, but I strongly believe that it's only through play and experimentation and the learning that results from that do we increase our knowledge of what the art of the possible actually is. Some people say play hard and wait hard. Completely agree with that. And I would say play and experiment and work and experiment. And by that means you can involve play in both your play and work. So in your personal play, not in your career, I would say, you can play and experiment in things like hackathons, open source contribution, side projects like I have, and little sort of learning tutorials as well. When it comes to business, I've seen this done to varying degrees of success. Play and experimentation is done okay by some businesses, not okay by others. Depends on very much the culture in the business. There's lots of different ways you can bring play and experimentation into the workplace, whether it's through innovation contests, 10% time, augmenting your tasks. That might sound boring. Even if you don't completely automate them, you might use technology, find a way to shave 5 minutes of your day. And then you don't have to come up with something that is going to revolutionize the business or come up with save hours and hours a day. This concept of marginal efficiency gains, which means even if you create an app which solves you a few minutes a day, saves you a few minutes a day, if you multiply that by the number of days you work over the years, multiply it by the number of people you share it with, back to sharing, right? With the business, that can help with business success, and you get this compound effect. So just because you're not revolutionizing something, there is this law of marginal efficiency gains, which compounds through play and experimentation and the learning that comes from that. And then the last AI example I want to show you is one that I did with generative AI. And this is because I really wanted to cut through a lot of the hype I was seeing around OpenAI and generative AI. Again, a lot of people saying how it was going to save the world or doom us all. It was going to revolutionize this industry or that industry or put us all out the jobs. There was very, very few examples I saw of actually people showing how to implement it, which I found really, really bizarre, almost a bit back to front. Surely the learning comes and then you talk about everything that it can solve for X. Anyway, I also wanted to learn the practical knowledge and skills, because if everyone's talking about this, suddenly it becomes valuable. I want a piece of that. I want to know how it works. I want to know how to program it. So I came up with this idea of generative AI tours, where I learned how to call the OpenAI API from code. Yes, I knew how to use the ChatGPT prompts, but I wanted to learn how I could actually create a solution that would take any prompt I could come up with, call OpenAI and return a result and use it in a particular scenario. This example I'm going to show you was actually finalist in the Worldwide AI Hackathon. So other people thought it was a pretty good idea this year. So I'm proud to mention that. So my idea was, what if you were going on holiday and you knew where you wanted to go, you knew the number of days you wanted to go for, and you could share the kind of interests you had. So maybe you're interested in photography and culture and shopping or history. And then when you select those different interests in your destination, it would come up with a prompt or a sentence, which would be something on the lines of, given you want to go on, recommend a number of activities on holiday in, I don't know, Paris for 3 days, given someone's interest in culture, wine tasting, photography. It'd send that off to OpenAI and then show you the results it came back with. And again, keeping it simple, starting from the beginning and experimenting and iterating on what I'd learned. The first version was rubbish. It didn't look good. It was all hard coded. The outputs were not very nice. But I'd learned through experimentation how to call the OpenAI and with a query or a prompt and return the results to the screen. That was the important takeaway. And then I used that and applied it to future versions, where I started making it look a bit better, formatting the output, showing the map that was resulted. Then I started bringing in the map, learned how to return the latitude and longitude for all the activities it was suggesting, plotted that on the map, and then going off and hit another API to return images for some of those activities. And then by version 4, iteration 4, I had something that looked like a website you would kind of expect, and a working prototype. But yeah, very much had learnt how that worked, and had to draw a line under that. Didn't really want to take it anywhere, but I could have monetized that if I wanted, could have put it live, but decided not to. I'd learned what I wanted to from that side project. Learned loads of things along the way. Things like sometimes the calls to OpenAI are a bit slow, so you might want to cache previous responses, which got me to thinking, right, if people are using the same combinations of filters, maybe I decided to try and hash the prompt that was generated using MD5 to create a unique string. I could save that as a key and the results that were returned previously for it. And then the next time someone selected that same combination of filters, I could see if that key was previously used, and then get the results from that were previously returned. Now, in reality, you wouldn't store it away on your local hard disk like I have, but again, just play with experimentation, keep it simple. In reality, you'd probably save that in a MongoDB database or in Azure Blob Storage or similar. But yeah, just learning the technology and then making it advanced and applying it to real world use cases. It is a value add because I tried this, it did work. It gave me some examples or some suggestions of places to visit when I went on holiday a few weeks later to Funchal in Madeira. I had a great time. And then this is an important takeaway. I mentioned this previously, but again, this is increasingly important, I think, with generative AI. It is so powerful and can be used in so many different scenarios and use cases. You just have to use your imagination. If your imagination is not that good, you're probably not in the right place if you're building innovative solutions. But your imagination is something you can improve if you use it more often. And if you don't use it very often, that skill of using your imagination is just going to dwindle as well. So always use your imagination as much as you can. Coming to the end of the talk now. So I also would recommend you turn theory into practice. And this is what I would call practical innovation, because it's only really through experimentation that practical innovation can be achieved. We can talk about innovation all day long. We can talk about different types of innovation or checklists for innovation or the benefits of innovation, how it can improve the bottom line of businesses. But it's only through practical innovation, creating something and delivering value, that you actually create value for the business. And I also say that you need to push the boundaries. So if you've always done if you always do what you've always done, you'll always get what you've always got. And pushing the boundaries is something that can feel uncomfortable because you're sometimes pushing yourself or other people outside the comfort zone. But it's only through pushing the boundaries that you'll really start to grow as people and businesses. I see sometimes people want drastic results all of a sudden. They want to 10x their sales or 10x their throughput, but they don't want to make drastic changes. They want these drastic benefits, but they don't want to make drastic changes. You have to push the boundaries and change a few things sometimes. And that hopefully is coming to the end of the talk now. So just to summarize, learning AI through play and experimentation. Experiment, because that's how you will learn new things. Try new things. That's the only way you will grow. Don't stop daydreaming. Keep using your imagination, because like a muscle, it'll atrophy if you don't use it. Push the boundaries. Try, and the only way you can increase the art of the possible is by pushing the boundaries. Otherwise, you'll always get what you'll always got. It might be uncomfortable, but that's the only way you're going to achieve growth. Build out your tool belt so that you can tackle solutions from lots of different angles and perspectives, and you're not just always approach different problems with the same single tool. Keep it simple, So learn how something works in as simple a way as possible first, and then apply more advanced ways or to more advanced scenarios afterwards. The implementation is more important than the idea. That is just true, I'm afraid. Um, Share your learnings. Sharing is caring. I'm only able to learn as quickly as I can through other people sharing, and I hopefully this is enable you to go off and encourage you to try and learn some other things as well. Show, don't tell, or if you're going to tell, show as well. There's too much telling and talk these days. If we're going to do practical innovation, we need to be showing real world examples of what we're talking about. Otherwise, you might as well be shouting into the void. Everyone's talking about innovation and AI. I much rather watch how people are actually implementing AI and seeing the value add that people are bringing to the world with AI, rather than just listening to people talking about it. Don't reinvent the wheel. If you don't have to, stand on the shoulders of giants and then tweak it for your own ends. Find and pursue opportunities, because they won't always come and land on your lap. But if they do, or if you find opportunities, grab them with both hands, because they are few and far between sometimes in this world. And the people that succeed are going to be the ones that grab these opportunities and run with them. And use your imagination. And most of all, have fun, because I keep talking about this fun. I strongly feel that you're only going to succeed in the things that you're passionate about. You're not going to succeed in things you're not passionate about. And that's why you should always try and do what you're passionate about, because that's the only way you're going to have fun and succeed at the same time. And I think that's the end of the talk, Magdalena. So yeah, just experiment, learn, and try new things. I'm on all the social medias. If you want to reach out to me on LinkedIn, Twitter, YouTube, TikTok, and GitHub. So reach out to me if you want. I don't mind. You can see other side projects I've done. But hopefully that's encouraged everyone to go off and learn and experiment and play next time you want to learn a new skill or technology. I hope you enjoyed that.
Leo, it was awesome presentation. I am very enthusiastic about saying this out loud, that we have to be passionate about what we are doing. Sometimes we can get the impression that we are a little bit crazy, but I do agree with this conclusion. Really, really, I do. And at the beginning, my road being outside of my box when I'm trying to be with my community, which is called Platform Poland. It was very hard for me, because for then I was the first woman in the community, so it was the double hard for me. And but it's so true that you are saying this out loud, because I think it's not only this one that we are showing what we got, showing what we learned, and showing how to do it, but who we are. And from my perspective, it's more important that I am a woman. I can present myself and what I have learned, and maybe my path is not so long, not as long as yours, for example, but it's important to present it, your words, and maybe someone else can find themselves in a, in a, okay, I can compare with her. I can see myself on the front of the screen, and okay, she's interested about this one and she can do it, so why couldn't I? So this is yeah, the last conclusion that you said on your presentation, I could sign up of each of them. So yeah, it was awesome. And I love that you present all your presentation with Lego blocks. I do like one.
Yeah,
I have
quite good idea.
I have my own. But I would like to ask you one thing. How many things did you presented us? Because I saw that with the car, I saw the troll, not troll, the Christmas tree troll, which was awesome from microwave. That I do understand. I do remember correctly. Yeah, it was a lot of things. Why? When do you have time for it?
Yeah, people ask me, "Oh, where do you find the time to do side projects, have two kids, and also, do your master's degree and do all this stuff?" I think you prioritize. It's all about prioritization. Everyone's got the same amount of hours in the day. Yes, people have got different circumstances, and some people are more fortunate than others with the amount of free time they have. But it has to come down to passion at the end of the day. You will be more inclined to stick with and focus on what you're passionate about. And for me, that's learning new technologies and sharing what I've learned. Um, I'm a Microsoft MVP, but that came after the sharing, the learning, and the sharing. It seemed like a natural continuation of what I was doing. And the best people, the best Microsoft MVPs I've seen, are the ones that have that passion for sharing and learning. And one of the things I like doing is sometimes getting people to think about things that maybe they've not previously thought about, like um, sharing about them learning agents. Other people might also wonder, well, how does a 2D car navigate around the track? But because I've shared it, now they don't have to go off and look it up. They can do that for themselves. Um, but yeah, it's again, a lot of it is natural curiosity as well. I'm a naturally curious person. So when generative AI suddenly became super popular, I found it really, really difficult to
Right.
scroll
Yeah.
down LinkedIn. I was looking for posts to see, right, how do I learn how to do this? Nope, there's someone just talking about it, talking about it, talking about it, talking about it. I found it really hard to actually find somewhere to go off and learn about it. So that when I did find out how it works, then I'll definitely go and tell others, just to cut through the hype and cut through the noise, quite frankly, that a lot of people talking about AI, but not sharing how to do it. And again, I'm not an AI expert. It's probably loads of faults in the stuff I've shared, but I'd like to think if I wanted, I could apply a lot of the skills I've learned to lots of different scenarios and get better. But yeah, I just, again, am passionate about it. That's how I find the time, because I'm passionate about it, I guess.
Okay, but Lee, do you find helpful, like to have on your mind that goal that okay, I can do it, I can manage with it, and I can share with it. It's at the end of the year of your journey of this long smallest journey. I think like another level. Okay, I can do it and I can share. I can do it, I can learn, and I can share. From my side, it was I don't know. Changer when I was the first one at the Baltic Summit. When I say hi to my colleagues, of course, and when I have this opportunity to share something from my side, it was a huge. Huge adrenaline to have this possibility opportunity, and to know that my knowledge is could be important for the others, could be something useful, and I write the blog and I write the post about it. But what I'm trying to say, that is another gratification for this journey, to and great to have community which are listening to you and they want to learn something more. But I do think so that is something that you want to that maybe the others wanted to know, that everything that you discover, that you just don't reinvent, you can put on the web and for the others, because there is always someone who not know this,
Yeah,
and great to have.
absolutely. Sometimes I'll search for answers to a problem, and the answer will be something I've previously posted, and I've forgotten I've forgotten that I posted it. So that gives me hope that other people were doing the same searches and finding answers to what I've shared. But I also think this element of fun is important, because there's lots of different ways to learn it. You can sit in a boring lecture at university and have facts drilled into you, and it's perhaps not the best way to learn. It's a way of learning, but I need it to be interesting to learn. So if we go, I did a website called visualstudiotips.co.uk, where I do a video on different tip of what you can do in Visual Studio. And Visual Studio is a great programming tool for developers.
Mhm.
And sharing that knowledge is great. But then I did a fun version of it. So one Christmas, I had my Christmas jumper on, had a green screen on, had a Santa's Christmas background with a tree, and had a different tip for every day, like an advent calendar, like a festive advent calendar. So again, if you can bring fun to the learning process and passion, then everyone wins.
And I think the most a lot of MVPs have that kind of sense of humor that is so magnetic for the others. To put this technology not as difficult as it is, but just with a fun way, and that's why it's so interesting to just watch it. And it was very nice. Oh, sorry. Okay, so uh, Lee, probably it's and our time as it's over. I see that someone say hi, Sinopix Films. I don't know who it is, but I would like to say one more that. You say a lot about having fun, and I find myself like a little bit ADHD, Okay, so it's very important to have this situation that I can have fun for my knowledge, for the learning path, because that is more. I'm more curious about it, and I know, and it's left in my head. It's left in my head bigger stamp. Yeah, so it's really good to know that it's important. Okay, Lee, can you give us all this tip? For example, link for your GitHub, for your Visual Studio with fun, and we just put in our YouTube channel, and then when everyone will watch it, you can go ahead to your sources. And for now, if you would like to say something, you can say it. Thank you very much. I am
Yeah, I
so.
just want to say thanks again for inviting me to speak. I love sharing technology. I like lowering the barrier of entry for other people. If one person goes off and learns about a technology I've talked about, then I've done my job. I can sleep better at night knowing that. Um, so yeah, like you said, follow me on Twitter, LinkedIn. I'd love to come back and talk about mixed reality, virtual reality, augmented reality. That's a passion of mine as well.
Yeah.
That's awesome.
I think that Veronica will take this one for her because she also have a passion for virtual. So yeah, I will leave her this. She told me that is your task to talk about. So yeah, it will be great. It will be great. Okay, but for now we have to just end this episode. Thank you, everyone. Thank you once again, Lee, and we are over.
Thanks. Bye now.